Hello everyone and welcome to my channel Utsuki. So in this video I'm going to show you my approach to turn system. So my turn system use a state machine. So I already made a video about state machine. But here and there it says that my face stumble upon two different types of state machines. One that use and hold current state as one single variable, and another one that you have an array of states. Okay, so in this turn system, actually you are able to use both. So let me start by showing the state script again. So I have two signals, state started and state stopped. So upon this state machine being started or stopped, this signal will be emitted. The name of this state machine that will be printed upon the state being turned on and off, and actually you can remove the print as well. The condition that is a callable, so you would actually link this condition callable to a certain method that return a boolean. So if you have a certain complex condition, you would need actually this, okay? So a remaining integer, so this state would be only started a certain amount of times. Duration timer and duration time limit, I already explained this a lot of times, but this is how I handle timers. So I have a timer that is a float number that would set a certain value, for example, and that would be decremented until reaches 0. Upon reaches 0, the event would happen and it will reset to the time limit value. Okay, so in the ready function I set both process to false. In the start function I check if the remaining is different from -1, so if it is set. If it is, I check if it's lesser or equals to 0, so there is no remaining times, so I return. Else I just decrement by 1. I print starting in the name of the state. I emit the state started signal, set both process to true, and I check if duration time limit is different from -1, so it is set. So the duration time is equal to this time limit. And in the process function, I check if duration time limit is set. If it is, I check if duration timer is greater than 0. If it is, I decrement by delta. Else, duration timer is lesser or equals to 0 and the state is being processed, I stop. I also have the condition part, so if condition is set, I create a variable result to hold the call of this condition. So if the result is true and is not processing, I start the state. But if the result is false and it is processing, it must be turned off. So I call stop. In the stop function, I print stopping the name of the state, emit the signal state stopped, and set both process to false. Okay? Now, here in the state machine, I have a timer as well, so timer and time limit. Here I have that variable, so I have a state machine of type state that would hold only one state. I have an array of states called current state, as you can see, and a state queue that is an array of states as well. I will explain soon. Here I have an enum of type and a variable holding this enum value. So here I have 3 possible types: a single state, state queue, and multi-state. So this type variable will hold by default single state, and this variable is queue loop equals to true. I will explain soon. So here in the ready function, I check if time limit is different from -1, so is set. So I set the timer equals to this time limit. Differently from that video, here the switch the switch method will be used for the queue to handle the single state. I actually have this method called switch state. I decided to make it this way. Okay, so This is a method of type void, so passing a parameter state. So if the type is not single state, so this method must not be used. So I check if the current state is set and is processing. If it is, I stop the current state. I check if the state passed in the parameter is valid, so I replace the current state and I start it. Okay, here had the switch method. So I check if the state queue is lesser. Like even though this lesser is impossible, you cannot have an array like with negative size. It's just because whatever. So I check if the state queue size is lesser or equals to 0. So if there is no state queue, or if the index passed is greater than state queue size -1. I already explained this a lot of times as well, but basically when you have an array, for example, of 4 positions, so the index actually goes from 0 to 3. So if you try to place a number that is greater than the size for -1, that is 3, so this index does not exist. So I return. I set the state is equals to the state queue pop at the index. So I remove this state from the state queue and I match the type. So if the type is state queue, I basically set the current state equals to this state and I start. Else, that is a multi-state, I start the state and actually I append the current to the current state. Okay, so it's removed from the state queue and appended to the current states. So I check if the queue is loop. So actually this state must go back to the end of the queue. If it is, I basically append this state again to state queue. Okay, I have this method called populate that will basically append the parameter state to the state queue, but I also commented this part because I wouldn't use and actually would be conflicted. But like this is where you would add the event sequence, right? So the possible turns or the possible events that would happen between turns. So here I check if I'm using the state queue and the state is not connected to the switch. So if not, I connect the state stopped signal to the switch. So this basically upon each state populated state emit the signal stopped. So the stopped, it will automatically switch to the next possible state, okay, because this would automatically call that the switch method passing the index, default index that is 0, okay. So this would be by default upon a certain state or turn being turned off, the next one would be played automatically, okay. And here in the process function, I check if the time limit is different from -1, so it is set. I check if the timer is greater than 0, I decrement by delta, else I reset the timer to the time limit, and I check if the single type is equal to single state, I call switch state, else I call switch. So this would basically turn off or go to the next state, okay, automatically based in the timer. So this timer would basically switch automatically the current state, okay. So I always create a very basic possible usage for the codes, right? So here in this, for example, I have this button a, right, and checkbox yay. Okay, so here I have a state machine called machine and a random state. In that video as well, I created each state individually. I create a node for them because the scripts are in the tab node. So I created each state as a node. And I set the things there. Here, I just am showing a different possibility where you set everything in the code, okay? I set the machine type equals to the single state. The name of this random state is equals to semicolon. I add this state to the state machine and I add the state machine to the scene. Okay, so that button a open being pressed, it will call machine.switchState passing the M. By pressing play, for example, so nothing happens, and open I touch this button, the state is so the state is started, right? And upon I click again, remember I'm calling switch state passing the M. So the current state would be turned off and the next one being started. Since they are the same, actually I'm starting and stopping the same state. Okay, so as you can see, I started the first time, then I stopped and started again. So let's go to the other possibility. So I will uncomment this remaining, so it's equal to 3. So actually, the switch state can happen only at best thrice, right? So I played 1, so it started 1. Then I click it again, it started and stopped. Then I click again, it started and stopped. Then I click again, it just stopped, didn't start. And it doesn't matter if I click again, as you can see, nothing happens because this state basically has only 3 chances, actually 3 times to be activated, okay? So let me uncomment this whole part and this as well. So what this code does, I connect to the signal state stopped to this function that would turn the button invisible. The machine has a timer limit equals to 2, and the timer as well, I will start in 2. And here I switch state. So what this will do, my state machine with a timer and time limit basically will switch the state, but my switch state basically turn off the current state. So this will basically turn off this state that will basically make the button invisible. Okay, so as you can see, open I hit play, I started, then stopped, and the button went away. Okay, and it doesn't matter how long I wait, basically this timer will turn off for good, let me put it this way, the single state machine. Basically this is a time limit for it work, okay? And now I will set the condition equals to the method check. If you see, the method check basically returns a boolean that is equal to the checkbox equals to button pressed. So basically my condition of this state machine will only be on while my checkbox is checked. Upon I unchecked, the condition will be false, so my state must be turned off. And even though if I try to turn this state again, it will automatically turn off because it does not have the checkbox checked. Okay, so here let me play. So the difference here, I just have that condition equals to check. Okay, so when I hit the button, my state would start normally, right? But when I uncheck the yay, as you can see, the state is stopped. And it doesn't matter if I try to start again, it will automatically stop. Okay, but if I check this again and press, it will only stay started. okay? So this might be used for example, you might have the possible, for example, the player can access certain things such as the shop upon a certain condition is true, or only in the beginning of the turn, and so on, okay? Or can only call for help or being healed thrice, or something like this, okay? So now let's go to the next example. So this example again is a very simple one. I have a button that is invisible and two labels, okay, in the end of each one. So pay attention to this label is in the upper left, this one is in the right, upper right, and this button is actually in the bottom right, okay? I will explain soon. So as I said, I wanted to set this manually for each thing, okay? But you can create nodes and attach the script for each one, or actually create a resource that would set everything automatically, okay? So I have this RNG that actually I don't need. This is just to talk about a certain possibility right soon. And I have two state machines, the player and the computer. So I'm actually simulating the possibility where the player is playing against the machine and actually is a turn-based game, for example. I have 4 states, so two are idle, so this idle state and player idle state, and the playing state and player playing state. So I name it computer idle, player idle, computer, and player, okay? I set both state machines equals to state Q, as you can see. I set the idle state, that is the computer idle, equals to 5, and upon the state being stopped, I switch only the computer state, and the player and the playing state as well. 5 seconds duration, and it will only alternate the computer state. Why is this? Because I wanted to make them independent. Because imagine, you can either have a very rigid turn-based something, or actually you are able for example, the player has its own turn system, turn part, and the other computers or the other players has their own turns as well. So in this case, each one of them would have their independent turn, and they would actually move as their own, okay? The player, same thing, as you can see, both the player idle and the playing has the duration equal to 5, and the idle as well just switch to the next state. But here is the difference. In the player playing state started, I will show the button change turn. So I will set the visible equals to true. And upon the player state, playing state is stopped, so I hide this button. And then as I switch the turn. So the only difference between this the player and the computer, it's because in the stopped I hide the button, and I also added a state started to show the button, okay? So I add the computer and the player state machines and add each state to its owner, okay? And I get a random number. So this rand f basically generates a random number between 0 and 1. It's a float number, so being over 0.5, the player will be populated first and then the computer, and else the computer will be populated first then the player. But this doesn't matter. What matters is the populate order. So if it's higher than 0.5, I actually add the playing state first and then the idle to the player, and to the computer the idle will be the first one and then the playing, and else the plain state for the computer will be first one, then idle, and for the player, the idle will be the first one, and then the plain state, and the whole change turn. I created this RNG. Okay, this is like useful for this as well. But if you have, for example, a turn-based game, but also you have global events, for example, these events would be added in here and in a random order and so on. So you would use this RNG, right, with a set seed, right? And okay, then I call change turn. So here here is the change turn method. So if the computer current state is not set and the player current state is not set as well, I call switch. So basically this will just switch the first state of both to the current one. Okay, remember it will use the index 0 and start it. Okay, else, so here I basically set the duration timer equals to 0. Why I do not use the switch state as well, since the switch will actually turn off the current state and then replace it, because I connect the signals, right? So if I didn't connect, you would be able to do it as well. But since I connected, I cannot turn off them manually, because this switch will turn off them and will emit the signal that would call switch again. Okay, so actually the state would change, and because of the signal it would change again. So you can either not connect the signal and actually calling every single time, or if you connect, actually you would reset the duration timer. Okay, and here in the process I check if the set state machine is valid and has a current state, so I can access the current state dot name and the states and the current state duration timer. Okay, so I will hit play here. So as you can see in the bottom right, I have the computer timer, and as you can see, when it's the idle, so the computer is not playing, you have computer idle. When it's the turn, I only have the computer and the player as well. So in the upper right, I have the player. When it's player idle, the player is not doing anything, and when it's only player, it's the player turn. And as you can see in the bottom right, I have a button that will only appear when it's the player turn and will disappear when the player is idle. And as you can see, I will press this button to finish my turn. So I hit. Now it's not my turn. Then I will hit again. Finish my turn. So as you can see, this turn system is working, right? As you can see, I'm starting and stopping each state. So this is already working. And why I wanted to make this first? So as I always say, I do not watch tutorials in order to make mine, okay? I already made a lot of games trying to make a turn-based something, but I always used booleans, and actually it was terrible. It was always terrible to reset things, to play certain animations, because I was using this boolean, and actually what controls the rest? So I decided to design this idea using state machines, because I thought it would be useful, and actually it worked. Okay, this was not only useful because of this, because our next step is something really meaningful. So when, like, I don't know how many years ago, maybe 5 or something like this, when I used to make games on Unity, I already heard about behavior trees, right? In quotes, that is the AI of the game, that actually you have not obviously the generative AI, you have a certain sequence of actions that a certain character would perform automatically, right? So actually it's their AI, their brains, let me put it in this way. So I was thinking about how could I make this, right? And I thought about certain games that use turn-based system, and I thought probably these behavior trees would work with these state machines with a certain queue of states. So since I have this condition callable, that's the main reason I added this, okay? Since I have these signals and these callables, I am able to chain states. So I am able to make a whole behavior, like a sequence of actions to make a behavior, and actually also, for example, having a resource or something like this, that upon a character finish input the state queue, go to the next thing. So imagine I have a character that goes from here to there to do something, and there to another there to do another thing, and upon finish go back here. So this I could, like, I don't know how I would make in a different ways, but using this turn idea and the behavior trees as well, I could have a resource that would store an array of states, okay? And upon the state is empty, I refill or repopulate with another resource with a bunch of new states. So I actually make the character goes from here to there, do another thing, go to there, to another there, do another thing, and then come back with this sequence of states, okay, with this turning idea, okay. So this is our big next step, but actually, to be honest, I would like to make another thing before I do this, okay? So you are able to think by yourself if you want, okay? So thanks for watching, and I'll see you in the next video. Bye.